Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be reviewing how to solve word problems involving systems of two equations and two unknowns. Let's look at example 1. Matt and Jessica are selling fruit for a school fundraiser. Customers can buy small boxes of oranges and large boxes of oranges. Matt sold 3 small boxes of oranges and 14 large boxes of oranges for a total of $203. Now I'm going to stop and highlight that information real quick, okay? Jessica sold 11 small boxes of oranges and 11 large boxes of oranges for a total of $220. What is the cost of 1 small box of oranges and 1 large boxes of oranges? So, first thing we want to do to solve a word problem is identify our unknowns and assign them in a variable. So in this problem, we do not know the cost of a small box. So I'm going to let X represent the cost of the small box. And we do not know the cost of a large box. So I'll let Y represent the cost of the large box. Now, after you identify your unknowns, then you're going to write 2 equations. Now, my first equation will come from what I highlighted in pink. 3 small boxes of oranges, so that would be 3x, plus 14 large boxes, so that would be 14y, was a total of $203. My next equation will come from what I highlighted in green. 11 small boxes, so 11x, plus 11 large boxes, so 11y, equaled a total of $220. Now, because both of these equations are in standard form, I'm going to solve by elimination. So let's try to eliminate our x's. So 3 will not go into 11, but if I multiply 3 and 11 together, I get 33. So I'm going to try to turn the top equation into positive 33 by multiplying it by 11. And I want to turn the bottom 11x into negative 33 by multiplying it by negative 3. So let's start with our top equation. Let's multiply everything in this top equation by 11. So 11 times 3x is 33x. 11 times 14 would be 154y. And 11 times 203 would give me 2233. Now on the bottom, negative 3 times 11x would be negative 33x. Negative 3 times 11y would be negative 33y. And negative 3 times 220 would be negative 660. Now, draw your line and add these 2 equations together. So the x's will zero out. Then we'll have 154 minus 33, which will give me 121y. And 2233 minus 660 will give me 1573. Now divide both sides by 21. And that gives me y equals 13. So y represented the cost of a large box. So I now know the cost of a large box is $13. Now to find the cost of a small box, I'm going to plug that value into the top equation. So 3x plus 14 parenthesis equals 203, and then substitute in the 13. So that would give me 3x. Let's see, what is 14 times 13? Would give me 182, and that's equal to 203. So 203 minus 182 would give me 21. So 3x is equal to 21. Therefore, x is 21 divided by 3, or 7. So the cost of the small box is $7. All right, example 2. Tickets to a play cost $12 for adults and $5 for children. If 300 tickets were sold for $2,620, how many of each type were sold? So in this problem, our unknowns is the number of adult tickets and the number of child tickets. So I'm going to let X represent the number of adult tickets sold, and I'm going to let Y equal the number of child tickets that were sold. Now, the first thing I want to do is write an equation that represents the total number of tickets sold. So I'll say the number of adult tickets, X, plus the number of child tickets, Y, has to equal a total of 300 tickets. Then I want to write an equation for the value of the tickets. Well, adult tickets were $12 each, so 12x. The child tickets were $5 each, so 5y. And that was a value, the total value of that added up to 2,620. Now, again, both these equations are in standard form. So I'm going to use elimination. So I'm looking at my x's. I have a positive 1x and a positive 12x. So what I think I'll do is try to turn that positive 1x into a negative 12 by multiplying everything in that equation by negative 12. So negative 12 times x gives me negative 12x. Negative 12 times y gives me negative 12y. And then negative 12 times 300 will give me negative 3,600. I'm not doing anything to the bottom equation, so let's just write it down underneath it. Now, let's add these two equations together. The x's will eliminate. Negative 12y plus 5y is negative 7y. Negative 3,600 plus 2,620 gives me negative 980. Then divide 980 divided by 7 will give me 140. So Y represented the child tickets. So I know there were 140 children's tickets sold. So now I'm going to take that value and plug it into the top equation. But for Y, I'll plug in the 140. And then to solve for X, all we have to do is subtract 140 from both sides. So 300 minus 140 will give me 160 adult tickets sold. All right, example 3. Josie has 14 coins, all dimes and quarters, worth $2.60. How many dimes and how many quarters does she have? So in this problem, we do not know the number of dimes or the number of quarters. So I'll let D represent the number of dimes, and I'll let Q represent the number of quarters. Now, you could have also used X and Y. I'll just use D and Q for this problem, all right? So just like in the ticket problem, the first thing we did was we wrote an equation for the total number of tickets. Here, I'm going to write an equation for the total number of coins. So the number of dimes plus the number of quarters has to add up to 14. I don't know why I wrote 140. Let me erase that. Yeah, so number of dimes plus the number of quarters is equal to 14 coins. All right. Now, remember in our ticket problem, after we wrote an equation for the total number of tickets, then we wrote an equation for the value of each ticket. Here, I'm going to write an equation for the value of the dimes and the quarters. So a dime is valued at 10 cents, or 0.10D. A quarter is valued at 25 cents, or 0.25 Q. And the value of those dimes and quarters was $2.60. Now, again, this is in standard form, so I'm going to solve by elimination. So I have a 1D and a 0.10D. I'm going to try to multiply this by negative 0.10 so that I can eliminate the dimes. So negative 0.10 times D is negative 0.10D. Negative 0.10 times Q is negative 0.10Q. And negative 0.10 times 1.4 would be negative 1.4. All right, now don't do anything to the second equation. And now we'll add these up. So the dimes would eliminate, and we have negative 0.10 plus 0.25Q would be 0.15Q. And then we have negative 1.4 plus 2.6, and that gives me 1.2. And then I'll divide 1.2 divided by 0.15. Whoops. 0.15. And that gives me quarters is equal. So I know now there are 8 quarters. Now, I'm going to plug that back into my top equation, and I'll plug in an 8 for the quarters and solve for the dimes. So 14 minus 8 is 6. So now I know there are 6 dimes. All right. Now, example 4 and 5, we're going to look at something called mixture problems. In example 4, it says you are making an acid solution in science class. 18 liters of a 40% acid solution are obtained by mixing a 20% acid solution with an 80% acid solution. How many liters of each must you use? So we do not know. We'll let X represent the number liters of the 20% solution, and we'll let Y represent the number of liters we need of the 80% solution. Let's see, 80% solution. So here's what's happening. We've got X liters of a 20% acid that you're mixing with X liters of an 80% acid, and you want to obtain 18 liters of a 40% acid. So what we're going to do first, just like the ticket problem and the coin problem, is we're going to write an equation for the total number of liters, which in this case, we want the number of liters of the 20% acid plus the number of liters of the 80% acid to add up to 18 total liters. Then we're going to write an equation for the value of each of those. So the 20% liters would be 0.20x plus the 80%, 0.80y, and then the value of the 18 would be 18, and we want it to be a 40% solution. Now, let me simplify that equation a little bit to be x, I need a little room here, x plus y equals 18, and 0.20x plus 0.80y equals 18 times 0.4, which would be 7.2. So all I did there was I simplified it by multiplying this out. All right. So now we can use elimination to solve this. So I'm just going to multiply this top equation by negative 0.20. And that would give me negative 0.20x minus 0.20y equals 18 times negative 0.2, which is negative 3.6. Don't do anything to the bottom equation. Now add these two equations together. So this would be 0.60y equals negative 3.6 plus 7.2, and that gives me 3.6. Now I'll divide. 3.6 divided by 0.6 gives me y equals 6. So y represented the 80% solution. So I know there are 6 liters of the 80% solution. So I'm going to take that and plug it back into my original equation. So I know x plus 6 is 18. So subtract 6 to get 12. So there are 12 liters of my 20% solution. All right, example 5. A jeweler needs to mix an alloy with a 16% gold content and an alloy with a 28% gold content to obtain 32 ounces of a new alloy that has 25% gold content. How many ounces of each of the original alloys must be used? So I'm going to let X represent the number of ounces of the 16% gold content, and I'm going to let Y represent the number of ounces of the 28% content. All right. Now, just like my ticket problem and my quarter and dime problem, the first thing I want to do is write an equation for the total number of ounces. And in this problem, it said we wanted to produce 32 ounces of the new alloy. So the number of ounces of the 16% alloy plus the number of ounces of the 28% alloy is going to equal a total of 32 ounces. Now I'm going to write an equation for the value of each of those. So x was 0.16x, y was 0.28y, and I want my final alloy to be worth 25%. That's the value of it. So what I want to do is rewrite this top equation. Don't do anything to it. And my bottom equation, 0.16x plus 0.28y equals, I need to multiply 32 times 0.25, and that gives me 8. This is the equation we're going to solve. So I'm going to multiply this top equation by negative 0.16. So that would give me negative 0.16x minus 0.16y equals 32 times 0.16, negative 5.12. Don't do anything to the bottom equation. And then we can add them together. So this would zero out, and this would be 0.12y equals negative 5.12 plus 8, 2.88, and then divide. So 2.88 divided by 0.12, that would give me 20. So I know there's 24 ounces of the 28% alloy. So I'm going to take that 24 and plug it back into my top equation. So x plus 24 equals 32. Subtract 24 from both sides, and we get 8. So there's 8 ounces of the 16% alloy. And that concludes today's lesson, solving word problems involving systems of two equations.